be going over the solutions from exercise 14.1 from the chapter Probability. So in the first question, they're asking us to complete the following statements. So in the first question, they've given that the probability of an event E plus the probability of an event not E is equal to blank. We know from the formula that P of E plus P of not E is equal to 1. So the answer for the first question is 1. In the second question, they're asking us that the probability of an event that cannot happen is blank. Such an event is called blank. So we know that the probability of an event that cannot happen is 0, and we know that the name for such an event is called an impossible event because the probability of that happening is 0. So the event is impossible to occur. In the third question, they're asking us that the probability of an event that is certain to happen is blank. Such an event is called blank. We know that the probability of an event that is certain to happen is equal to 1, so the answer for the first blank is 1, and we know that the name of such an event is called a sure event, so that is the answer for the second blank. In the fourth question, they're asking us the sum of the probabilities of all elementary events of an experiment is blank. We know that the sum of all elementary events is equal to 1. For example, the tossing of a coin is an elementary event, so the probability of getting heads is 1 over 2, the probability of getting tails is 1 over 2. Both of them are elementary events. When we add them together, we will get 2 by 2, which is equal to 1. Next, in the fifth question, they've given that the probability of an event is greater than or equal to blank and less than or equal to blank. We know that a probability of an event is greater than or equal to 0 and less than or equal to 0. So the probability of an event lies from 0 to 1, but cannot exceed 1 or be less than 1. Moving on to the second question. They have given that we need to figure out which of the following experiments have equally likely outcomes, and we need to explain why. So the first question, they've given that a driver attempts to start a car. The car starts or does not start. So in this scenario, the outcome of the car starting or not starting depends on various factors that are not stable. For example, the car getting started or not getting started can depend on how old the car is, that there's enough fuel in the engine, and etc. And the factors on which the car will start or will not start are not the same and vary. Thus, we can conclude that it is not an equally likely event. In the second question, they're given that a player attempts to shoot a basketball. He shoots or misses the shot. The outcome of the player shooting the basketball into the hoop depends on various factors such as this basketball player's skill, the distance from which he is at the hoop, whether he knows how to play, and there are many other factors which go into determining whether the ball will go into the basket or not. Since the factors on which the outcome depends is varying, we can say that it is not equally likely event. Next, in the third question, they've given that a trial is made to answer a true or false question. The answer is right or wrong. So in this scenario, the probability of getting the true answer or the false answer is 50-50. So thus we can say that it is an equally likely outcome. Moving on to the fourth question, they've given that a baby is born. It is a boy or a girl. The two outcomes that are possible for this event is either the child is a boy or the child is a girl. And both of those outcomes are equally likely outcomes. Thus we can say that the fourth scenario is an equally likely event. In the third question, they've given that why is tossing a coin considered to be a fair way of deciding which team should get a ball at the beginning of a football game. So when we toss a coin, there are two possible outcomes, either heads or it can be tails, and the probability of getting each would be 50-50. So we can say that it is an equally likely outcome. And the result of an individual toss is completely unpredictable. So these two are the factors which determine why we use the tossing of a coin to determine which team should get a ball at the beginning of a football game, because it is a fair event where both events are equally likely outcomes. In the fourth question, they've given that which of the following cannot be a probability of an event. We know that an event needs to be greater than or equal to 0 or less than or equal to 1. And from the given options, it is blatantly obvious that the second option, minus 1.5, is less than 0, so it is not possible for it to be the probability of an event. So the answer choice would be B. In the fifth question, they've given that P of E is equal to 0.05. What is the probability of not E? We know that the probability of E plus the probability of not E is equal to 1. So 0.05, which is probability of E plus P of E naught, is equal to 1. We're going to isolate P of E naught is equal to 1.00 minus 0.05, which is equal to 0.95, which is equal to the probability of PE naught. In the sixth question, they've given that a bag contains lemon-flavored candies only. Melanie takes out one candy without looking into the bag. What is the probability that she takes out one an orange-flavored candy? So they've clearly mentioned that the bag only has lemon-flavored candies. So the probability of her getting an orange candy out of the bag is clearly 0. So that means it's an impossible event. And the probability of getting a orange-flavored candy is an impossible outcome. Thus we can say that the probability is 0, and it is an impossible event. In the second case, they're asking us the probability of her getting an orange-flavored candy. So the probability of her getting an orange-flavored candy would be 1, because the types of candies in the bag is only lemon-flavored candies. And in the second question, they're asking us the probability of her getting a lemon-flavored candy. And since there are only lemon-flavored candies, the only possible option of the type of candy that she would get when she takes a candy from the bag would be lemon-flavored. So that means the probability of her getting a lemon-flavored candy would be 1, and it is a sure event. In the seventh question, they've given that it is given that in a group of 3 students, the probability of 2 students not having the same birthday is equal to 0.992. What is the probability that the 2 students have the same birthday? So they've given that P of E naught is equal to 0.992. We need to find the probability of the event happening. So we know from the formula that P of E plus P of not E is equal to 1. So when we substitute the value of P of not E is equal to 0.992, we will get P of E is equal to 1.000 minus 0.992, which is equal to 0.008, which is the probability that 2 students will have the same birthday. In the eighth question, they've given that a bag contains 3 red balls, 5 black balls. A ball is drawn at random from the bag. We need to prove the probability that the ball drawn is 1 red. So the total number of balls would be 3 red balls plus 5 black balls, which is equal to 8. So the probability of her getting a red ball would be 3 by 8, because there are 3 red balls and the total number of outcomes is 8. So the event favorable to E, which is getting a red ball, is equal to 3. So 3 over 8 is equal to the probability of her getting a red ball. Second question is the probability of her getting a ball that is not red. So the probability of her getting a ball that is not red would essentially be the probability of her getting a black ball, which is 5 over 8. But we can also use the formula P of E plus P of not E is equal to 1, where P of not E is equal to 1 minus the probability of her getting a red ball, which is 3 over 8. So we will get P of E naught is equal to 8 minus 3 over 8, which is equal to 5 by 8. So the answer for the second question can be found either through this or by saying the probability of getting a black ball, because both of them mean the same thing and are the same answer. In the ninth question, they've given that a box contains 5 red marbles, 8 white marbles, and 4 green marbles. 1 marble is taken out of the box at random. What is the probability that the marble taken out will be 1 red? So they've given that the total number of marbles would be 5 plus 8 plus 4, which is equal to 17. So the probability of her getting a red ball would be 5, which is the number of red marbles, over total number of marbles, which is 17. So the probability of her getting a red marble would be 5 over 17. In the second question, they're asking us to find the probability of her getting a white marble. The total number of marbles is 17. The total number of white marbles is 8. So the probability of her getting a white marble would be 8 over 17. Third question, they're asking us to find the probability that the marble will be not green. So for the probability of the marble to be not green would be the sum of the outcomes that are not green. So the sum of the outcomes that are not green is 5 plus 8. 5 plus 8 is equal to 13. So 13 over 17 will give us the probability of not green. In the 10th question, they've given that a piggy bank contains 150 paise coins. So there are 150 paise coins, 50 rupees 1 coins, 15 1 rupee coins, and 20 2 rupee coins, and 10 5 rupee coins. So if it is equally likely that one of the coins will fall out when the piggy bank is turned upside down, what is the probability that the coin 1 will be 50 paise? So in order to find the probability that the coin will be a 50 paise coin, we need to first figure out the number of 50 paise coins, which they've given is 100, and the total number of coins, which is 50 plus 50 plus 20 plus 10, which is equal to 180. So the probability of it being a 50 paise coin would be the number of 50 paise coins, which is 100, divided by the total number of coins, which is 180. So when we simplify it, we will get 5 over 9, which is the probability. In the second question, they're asking us to find the probability that it will not be a 5 rupee coin. So in order to find the probability that it will not be a 5 rupee coin, first we need to figure out the number of 5 rupee coins there are. So we know that there are 10 5 rupee coins. So the probability of it not being 5 rupee coins is 180, which is the total number of coins, minus 10, which is the number of 5 rupee coins, which is equal to 170. So 170, which is the probability of it not being a 5 rupee coin, divided by the total number of coins, is equal to the probability, which is equal to 170 divided by 180. Where we cancel out zeros, we will get 17 over 18. In the 11th question, they've given that Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out 1 fish at random from a tank containing 5 male fish and 8 female fish. What is the probability that the fish taken out is a male fish? So in order to find the probability of it being a male fish, we need to first figure out the total number of fish. The total number of fish is given by the number of female fish plus the number of male fish, which is equal to 5 plus 8, which is equal to 13, which is the total number of outcomes. Now we need to find the probability of it being a male fish. The number of male fish are 5, so 5 over the total number of fish, which is 13. 5 over 13 will give us a probability of the fish being taken out being a male fish. In the 12th question, they've given that a game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8. And these are equally likely outcomes. They're asking us to find the probability that the arrow will point at 1, 8. So there are a total of 8 possible outcomes, and only one of the outcomes is 8. So 1 over 8 will give us the probability of the arrow pointing at 8. The second question, they're asking us to find the probability of it being an odd number. The total number of odd numbers would be 1, 2, 3, 4. So 4 over 8, which is equal to 1 over 2. In the third question, they're asking us to find the probability of the number being greater than 2. So the numbers greater than 2 are 3, 4, 5, 6, 7, 8, which is 6. So 6 over 8 will give us 3 over 4, which is the probability of the number being greater than 2. In the fourth question, they're asking us to find the number less than 9. The total numbers present on the circle are 1 to 8. So all of the numbers present on the circle are below 1. So the number of outcomes favorable to E, which is the number is less than 9, is equal to 8. So 8 over 8 is equal to 1, and it is a sure event. In the 13th question, they've given that a die is thrown once. Find the probability of getting 1, a prime number. So the total number of outcomes when a die is thrown is 1, 2, 3, 4, 5, 6. So first question, they're asking us to find the probability that it is a prime number. So the number of prime numbers in the range of numbers present on the dice are 2, 3, and 5. So 3 divided by 6 will give us 1 over 2, which is the probability of the number being a prime number. Next, in the second question, they're asking us to find the probability of a number lying between 2 and 6. So the number of numbers lying between 2 and 6 are 3, 4, and 5, so 3 numbers. So 3 divided by the total number of outcomes, which is 6, 3 over 6 will give us 1 over 2, which is the probability of the number lying between 2 and 6. In the third question, they're asking us to find the probability that the number will be an odd number. So the number of odd numbers present between 1 and 6 are 1, 3, and 5. So 3 over 6 is equal to 1 over 2, which is the probability of a number being an odd number. In the 14th question, they've given that one card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of red color. So we know that there are 4 suites in a deck of cards. There are 52 cards in a deck, and the total number of kings of red color are 2 because there are 2 red suites, which are the hearts and the diamonds, and there are there is 1 king of hearts and 1 king of diamonds, so there are 2 kings of red color in total. So the probability of getting a king of red color would be 2 over 52. The second question, they're asking us to find the probability that it is a face card. We know that there are 4 suites, and each suite has 3 face cards, namely the king, queen, and jack. So the total number of face cards would be 3 times 4, so 12. So the total number of face cards are 12. And we know the total number of cards are 52, so 12 over 52 will give us 3 over 13, which is the probability of getting a face card. In the third question, they're asking us to find the probability of getting a red face card. So we know that there are 2 red suites, namely the diamonds and the hearts, and there are 3 face cards in each suite. So there are 3 face cards for the diamond suite and 3 face cards for the hearts. So 3 plus 3 is 6, so 6 would be the probability of getting a red face card. So 6 over 52 is equal to 3 over 26, which is the probability of getting a red face card. In the fourth question, they're asking us to find the probability of getting a jack of hearts. So we know that there is 13 cards in the heart suite, and there's only 1 jack of hearts. So the probability of getting a jack of hearts out of 52 cards in a deck would be 1 over 52. In the fifth question, they're asking us to find the probability of getting a spade. There are 4 suites in a deck of cards, out of which 1 is a spade, and the number of cards in the suite of the spades is 13. So 13 over 52 will give us the probability of getting a spade. In the sixth question, they're asking us to find the probability of getting a queen of diamonds. There is only 1 queen of diamonds. There is 1 queen of diamonds in each suite. There are 4 suites in total, but getting a queen of diamonds, there's only 1 queen of diamonds, so 1 over 52 will be the probability of getting a queen of diamonds. In the 15th question, they've given that 5 cards, the 10, jack, queen, king, and ace of diamonds, are well shuffled with their face downwards. 1 card is being picked up at random. 1. What is the probability that the card is the queen? We know that there are 5 cards in total, 1 queen, so the probability of getting a queen would be 1 over 5. Second question, they're asking us to find the probability that if the queen is drawn and put aside, what is the probability that the second card picked up is 1, A, an ace, B, a queen. So since 1 card is taken and put aside, there are a total of 4 cards remaining, out of which 1 is an ace, so 1 over 4 will give us the probability of getting an ace. B, they're asking us to find the probability of getting a queen. Since there was only 1 queen in the beginning and we took that card and put it aside, there are no queens remaining in the 4 cards left, so 0 would be the probability of getting a queen because it is an impossible event. In the 16th question, they've given that 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from the slot. Determine the probability that the pen taken out is a good one. So first we need to find the total number of pens. The total number of pens is the total defective pens plus the total good pens. So it will be 12 plus 132, which is equal to 144. Next, they're asking us to find the probability of getting a good pen. We know the number of good pens are 132, so 132 over 144 will give us 11 over 12, which is the probability of getting a good pen. In the 17th question, they've given that a lot of 12 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? So there are a total of 20 bulbs, and the number of defective bulbs are 4. So the probability of getting a defective bulb would be 4 over 20, which can be simplified as 1 over 5. Second, they're asking us to find that if the bulb is not defective and is not replaced, now one bulb is drawn at random from the rest, what is the probability that this bulb is not defective? Since we started off with 20 bulbs and we're taking one bulb out and keeping it aside, there will be 19 bulbs left in total. And the number of non-defective bulbs would be 19 to minus 4, which is equal to 15. So the probability of getting a non-defective bulb would be the number of non-defective bulbs divided by the total number of bulbs, which is 15 over 19, which is the probability of getting a non-defective bulb. In the 18th question, a box contains 90 discs, which are numbered from 1 to 90. If one disc is drawn from random from the box, find the probability that it bears 1, a 2-digit number. So the number of 2-digit numbers from 1 to 90 will start from 10, 11, 12, 13, all the way up to 90. We will notice that all of these numbers form an AP. So here the first term would be 10, the value of D would be 11 minus 10, which is equal to 1, and AN is equal to 90. So we can say 90 is equal to 10 plus N minus 1 times 1. 90 is equal to 10 plus N minus 1. 90 is equal to 9 plus 9, 9 plus N, and 90 minus 9 is equal to N. So the value of N is equal to 81. So there are a total of 81 2-digit numbers. So 81 divided by the total numbers, which is 90, 81 over 90 is equal to the probability of us getting a 2-digit number. Next, they're asking us to find the probability of us getting a perfect squared number. So the number of perfect squares from 1 to 90 would be 1, 4, 9, 6, 36, 49, 64, 81. So there are a total of 9 perfect square numbers. So the probability of getting a perfect square would be 9 over 90, which is equal to 1 over 10. In the third question, they're asking us to find the probability of getting a number divisible by 5. The total number of numbers divisible by 5 from 1 to 90 are 18. So 18 divided by 90 will give us the probability of a number being divisible by 5. So 18 divided by 90 can be simplified as 1 over 5. In the 19th question, they've given that a child has a die whose 6 faces are shown as the letters given below, A, B, C, D, E, and A. They're asking us to find the probability, if the die is thrown once, of getting A. So first, there are 2 A's in the given set of letters. So 2 over the total number of letters, which is 6, will give us the probability. So 1 over 3 will give us the probability of getting A. Second question is the probability of us getting the letter D. So there is 1 D out of the 6 letters, so the probability of getting D would be 1 over 6. In the 20th question, they've given that suppose you drop a die at random on the rectangular region shown in figure 15.6. What is the probability that it will land inside the circle with diameter 1? So in order to find the probability of the dice landing inside the circle, we need to find the probability would be given by the area of the circle divided by the area of the rectangle. They've given us the dimensions of the rectangle to be 3 and 5, so 3 into 5 will give us 3 and 2, so 3 into 2 will give us the area of the rectangle, which is 6. they've given us the diameter of the circle, which is equal to 1, so the radius would be 1 divided by 2, which is equal to 1 over 2. The area of the circle is pi r squared, so pi times 1 over 2 times 1 over 2, which will equal to pi over 4. And since the probability of the dice landing on the circle is the area of the circle divided by the area of the rectangle, we can write that as pi over 4 by 6. And when we bring 6 over to the denominator when we multiply it, we will get pi over 24, which is the probability of the die landing in the circle. In the 21st question, they've given that a lot of 144 ball pens, of which 20 are defective and the others are good. Nuri will buy a pen if it's good, but will not buy it if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it? So we know that Nuri will only buy the pen if it is a good pen. So we need to find the total number of good pens. And there are total of 144 pens and 20 which are defective. So 144 minus 20 will give us the number of good pens. So 144 minus 20 is equal to 124, and 124 over the total number of pens, 144, will give us the probability. When we simplify this, we will get 31 over 36, which is the probability of Nuri buying the pen. In the second question, they're asking us to find the probability that she will not buy it. So the probability of her not buying it would be 1 minus the probability of her buying it. So P of E naught is equal to 1 minus P of E. P of E naught is equal to 1 minus 31 over 36. And P of E naught is equal to 5 over 36. In the 22nd question, they've given that 2 dice, 1 blue and 1 gray, are thrown at the same time. We need to write down all the possible outcomes and complete the table. So the first column is some event, which is the sum of 2 dice. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And the second column is the probability of getting the sum of the 2 dice. So the probability would be 1 over 36, 1 over 18, 1 over 12, 1 over 9, 5 over 36, 1 over 6, 5 over 6, 4 over 36, 3 over 36, 2 over 36, and 1 over 36. In the second question, they're asking us that if a student argues that there are 11 possible outcomes, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Therefore, each of them has a probability of 1 over 11. Do you agree with this argument? From the given table, we will notice that the probability that each term does not have a probability of 1 over 11. So that means his statement is incorrect. In the 23rd question, they've given that a game consists of tossing 1 rupee coin 3 times and noting its outcome each time. Hanif wins all of the tosses given the same result, 3 heads or 3 tails, and loses otherwise. We need to calculate the probability that Hanif will lose the game. So the total number of outcomes is 8, because she's throwing 1 rupee coin 3 times. So we will get H, 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 T, H, T, H, T, H, T, H, T, T, H, T, H, T, T, and T, T, T. So there are a total of 8 outcomes. So the number of outcomes where Hanif loses the game is 8 minus 2, which is 6. So the probability of her losing the game would be 6 over 8, which is equal to 2 over 4. In the 24th question, they have given that a die is thrown twice. What is the probability that 1, the die will not come up either, 5 will not come up either time? So the total number of outcomes where 5 does come up is equal to 11, and the total number of outcomes is 36. So the probability that the total number of outcomes where 5 will not come would be 36 minus 11, which is equal to 25. So 25 over 36 will give us the probability of the outcome where 5 will not come up. The second question, they're asking us to find the probability where 5 will show up at least once. So we've already found out that 5 shows up 11 times, so 11 over the total number of outcomes, 36. 11 over 36 will give us a probability of 5 coming up at least once. In the 25th question, they've given that which of the following arguments are correct and which are not correct. Give reasons for your answer. If 2 coins are tossed simultaneously, there are 3 possible outcomes: 2 heads, 2 tails, or 1 of each. For each of these outcomes, the probability is 1 over 3. So let us first test out the question, what they're asking. So the total number of possible outcomes would be h, h, t, t, h, and t, t. So the total number of possible outcomes is 4. So the probability of getting 2 heads would be 1 over 4, which is not equal to 3. So from that, we can say it is incorrect. Similarly, the probability of getting 2 tails would also be 1 over 4, which is not equal to 1 over 3. And the probability of getting 1 head and 1 tail is equal to 1 over 2, which is not equal to 1 over 3. So the first statement is incorrect. The second statement states that if a die is thrown, there are 2 possible outcomes: an odd number or an even number. Therefore, the probability of getting an odd number is 1 over 2. So we know that the probability of us getting an odd number is 3 over 6, because in a dice there is 1, 2, 3, 4, 5, 6. There are 3 odd numbers, so 3 over 6 will give us the probability of us getting an odd number. Similarly, there are 3 even numbers in 1, 2, 3, 4, 5, 6. So 3 over 6 will give us the probability of us getting an even number. So in both cases, the probability is 1 over 2, so that we can say that the statement is correct.